Hi guys, this is Mrs. Holmer, and we are going to be doing the second part of the Hardy-Weinberg problem set number 1. So if you had some trouble with the problems at the end, I am going to go a little bit faster since I've already gone through the first 5 pretty slowly. And so if you have questions or whatnot, you can always let me know or contact me, and I will help you with whatever your questions are. So let's get started. In this one, it says the homozygous dominant genotype. So they're talking about P squared here, and it said it's made up 35%. Then it asked me what are the frequencies of the big A and little a alleles. So it's kind of asking me a question, and then I've got an answer down here. So we'll figure out where to put these two answers. So the first thing I'm going to do is P squared equals 0.35. And I always tell you to find P first or Q first as quickly as you can. So P is going to be the frequency of the dominant allele, so the frequency of capital A. And so I'm going to do the square root of 0.35. And for my calculator, I have to put the square root key in first. Sometimes you don't. Sometimes you hit the number and hit the square root. So you got to figure it out for your calculator. And my answer is 0.59. Keep 2 decimals. Here, the 1 does not round that 9 up, so just 0.59. The frequency is A is Q, so the recessive allele. And so remember, P plus Q equals 1. So I'm just going to do 1 minus 0.59. And my Q value is 0.41. So those two add up to 1. Now it wants the frequency of the heterozygous. So that's going to be 2PQ. So 2 times 0.59 times 0.41. That gives me 0.48. The 3 does not round that 8 up to a 9. But we keep 2 decimals. The frequency of the dominant trait, that's going to be a little bit different. So dominant trait, remember, is the P squared plus the 2PQ. Because both of those genotypes have the dominant trait. But there's a simpler way of finding the dominant trait. So I'm adding next year to this worksheet the frequency of the recessive trait. Well, the recessive trait is to the recessive genotype, because to have the recessive trait, you have to have the recessive genotype. So the recessive trait is just equal to Q squared. So that one's easy. My Q squared value is 0.41 squared. So that's 0.17. And so to find the dominant trait, I can just do 1 minus Q squared, or 1 minus 0.17, and that's going to give me 0.83. I could do P squared plus 2PQ if I'd like. So 0.59 is my P squared, my P value squared. Or I guess they already told me P squared is what? 0.35. I found the heterozygous, which is 0.48. 0.35 plus 0.48. Get this in there correct. And that gives me 0.83. So that's good, because that's the way I got the number I got when I calculated it the other way. So again, it's so much easier to remember that the dominant and recessive trait add up to 1. The recessive trait is just Q squared. So then the dominant trait is 1 minus Q squared. Okay. In the next problem. All right, so let's go ahead and do question number 6. In a population of 3,000 fruit flies, 270 of them contain white eyes, which is a recessive trait. So I'm going to take 270 divided by 3,000. And that's going to give me 0.9. Now, this is the recessive trait, white eyes. But remember, the recessive trait has to have the recessive genotype. So what they have given me is Q squared is 0.09. Sorry, I left a 0 off here, 0.09. So now I can find the rest of my values. So this one says, what is the allelic or the allele frequency for the red eye allele? Well, red eye is dominant, so that's P. And this one, the allelic frequency for the white eye allele, that's recessive, so that's Q. So I'll start with Q. It's the square root of 0.09. So the square root of 0.09. Be careful you get that extra 0 in there. And that gives me a Q value of 0.3. So my P value is 0.7 because these two have to add up to 1. And then heterozygous red, 2PQ is heterozygous. So 2 times 0.7 times 0.3 equals 0.42. And so that is my frequency of the heterozygous genotype, as they would be red. All right, question number 7. An investigator has determined by inspection that a human population of 500 alleles in the gene pool are dominant. Complete all the genotype and allele frequencies for this population, assuming it is in Hardy-Weinberg equilibrium. So that just is telling me that I can use these formulas. All right, well, this one's kind of tricky because 500 in the gene pool are dominant. So my number of dominant alleles is 500, and I want to divide that by my total number of alleles, which is twice my population. So my population of 500, I would have 1,000 alleles in my gene pool. And so we would do 500 divided by 1,000, and that is going to give me the answer of 0.5. And this is the dominant allele, so this is going to be my p-value. P is 0.5. Well, that means if P is 0.5, Q is also 0.5. My p-value, 0.5 squared, 0.25. Q would be the same because P and Q are the same. And then 2PQ, 2 times 0.5 times 0.5 gives me 0.5. Now I've added in here again for next year, I'm going to be adding in the dominant and recessive trait. So it's good for you to see what is the frequency of the dominant and recessive trait. Well, the recessive trait is always equal to Q squared. So the recessive trait would be 0.25. The dominant trait is 1 minus Q squared, or 1 minus 0.25, which is 0.75. You can also do P squared plus 2PQ, which would be 0.5 plus 0.25, which is still 0.75. All right. A large population of laboratory animals has been allowed to breed randomly for a number of generations. After several generations, 81% of the animals display a recessive trait. So they have little a. So this is Q squared right now. So we have been given Q squared equals 0.81. So now I want to know the frequency of the allele little a. So this is the recessive allele, so I want to know what my Q value is. So I'm going to take the square root of 0.81, and that gives me 0.9. Then it says what frequency is heterozygous for this trait. Well, I need my P and my Q value. So I know what my Q value is. So real quick, I'm going to calculate my P value is 0.1 so that I can plug it into this formula. 2 times 0.1 times 0.9. And that gives me 0.18. So now if I want to know how many in the population would be heterozygous, I would take that frequency, which is 0.18, times my population, which is 3,400. And that gives me 612 members of the population have the heterozygous genotype. All right. There's an answer key that will show you how to do the rest of the questions. So if you have any questions with 9 through 11, you can see me. But otherwise, if you have any more questions, please see me in advisory or during class, and I can help you with it. Good luck.